Okay, I just want to pick up the second half of this this lesson, which is on standard deviation. So the third learning target of the unit is standard deviation. So we've seen, like, for normally distributed data, there's a certain percentage of data that's a certain number of standard deviations above or below the mean. So we kind of talked about that before, how there's 68%. Even though not all data are normally distributed, these percentages will no longer hold when it's not normally distributed. It still gives you a good picture of what standard deviation means. It's useful to point out that not all data is. Like, you could have class marks that are not. You could have heights of people in a classroom that aren't. You could have heights of a collection of students that aren't normally distributed. So it's helpful to know that some things are not normally distributed. But standard deviation still gives you an idea of the normal distribution still gives you an idea of what standard deviation means. It means, like, not exactly, but one standard deviation above, one standard deviation below. You have roughly about two-thirds of the data, or 68%. A deviation is the difference between the mean and an individual data point. Standard deviation is the average deviation, how far a typical data point is from the mean. If most of the data is clustered around the mean, the standard deviation will be small, so little dispersion. If the data is widely scattered, the standard deviation will be large. The smaller the standard deviation, the more compact the data. Therefore, the more consistent the data. So we could suspect that the CHAMPS data, the CHAMPS versus the Superburger, the CHAMPS would probably have a lower standard deviation. To solve for standard deviation, you find the variance, which is sigma squared, and you take the square root. So this is how we calculate standard deviation. Ours are all going to be samples. Like, we're always going to assume that we're sampling a population. And so it's just for simplicity, like, we're only going to look at this formula. But I wanted to make you aware that there is a formula out there that doesn't do n-1, the total minus 1. It takes just the total. And this is a calculation where you do have the total. This n-1 is just a correction for the fact that it's a sample. But, like, this is just a demonstration of a standard deviation that's actually calculated. So if you actually calculate the average, you can calculate is 31. You can calculate the variance by taking the difference each point is from the average and squaring them. We're going to find the average of those. So there's 4 of these differences, so we're going to divide by 4. That's what the n does down here. And we get 17. That's what we call the variance. We take the square root of that, we get 412. So standard deviation is 4.12. So on one of these points is on average 4.12 from 31. Okay, it's a really low sample, low population. It's only 4 test scores, but that's how you'd actually calculate a standard deviation. In general, we use the population if you have everybody, and the sample if you don't. But we're just going to keep using the sample, and that's what we're going to use when we calculate standard deviation with Fathom. It'll be using this formula. When there's more data points, which really there has to be a little bit more data points, they're going to be so close together anyway that it doesn't really matter. But for now, we're actually going to focus on using the sample standard deviation. Okay. So using Class A and Class B data, we're going to calculate the measures of spread and compare the classes. If you want to watch the next video, we're actually going to take time to do that. Okay. So for practice, if you want to look at these questions here, that will practice IQR and standard deviation.